Hi students, welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic today going to discuss is from chapter 9, Ray Optics and Optical Instruments. Already in previous session we have given 7 questions and we are going to discuss the solution and solving the solution for that 7 question from these chapters. Let's move to first question. An object is placed on the principal axis of a concave mirror at a distance of 1.5 f. 1.5 times f. Here f is the focal length of the mirror. The image will be at dash. I think most of you may got answer. Option A, minus 3f is the correct answer. We know the mirror formula. Formula used here is 1 by f equal to 1 by u plus 1 by v. And here concave mirror at a distance of 1.5 f. That is objective distance is given and we want to find image distance. Object distance u, object distance u equal to given, that is 1.5 f. And you should find image distance v. You should find. Okay. So 1 by f equal to 1 by u plus 1 by v, then 1 by v equal to 1 by f minus 1 by u. And for mirror, concave mirror, object as well as image both will be obtained the same side, left hand side. So already we know sign convention. According to sign convention, if the image or anything comes in left hand side, then we will put negative. Therefore, u equal to 1.5 f. Also, for concave mirror, focal length f equal to in negative value. Then substitute this here. 1 by v equal to 1 by v equal to 1 by f, that is 1 by minus f, and then minus 1 by 1.5 minus f becomes plus 1 by 1.5 f. F take outside and simplify. 1 by f into 1 by 1.5 plus I'll keep first 1 by 1.5 minus 1. To simplify 1 by 1.5 minus 1, that is 1 minus 1.5 whole divided by 1.5. 1 minus 1.5 is 0.5 and that is minus 0.5. Therefore, this is equal to minus 0.5 f. Okay. F into 1.5 into 1.5. And to simplify this, 1 times 3 times. Then 1 by v equal to minus 1 by 3 f. 1 by v equal to 1 by 3 f. Then v equal to 1 by e equal to minus 1 by 3 f. V equal to, that is v equal to reciprocal, that is minus 3 f. Minus 3 f. So which option? Option A. Option A is the correct answer. Let's move to problem number 2. If the critical angle for total internal reflection from a medium to vacuum is 45 degree, then velocity of light in the medium is dash. Which option? Yes, B option is the correct answer. That is 3 by root 2 into 10 power 8 meter per second. And we know the formula, that is a relationship between mu and sine C. What is C? C is the critical angle, which is very important for total internal reflection. What is total internal reflection? It is the basic principle for propagation of light through optical fiber. Then nu equal to 1 by sine c, and critical angle value 45 degree given. Then so two formula we are using. First one, mu equal to 1 by sine c. In this, mu equal to 1 by sine, what is the value of c? 45 degree. Sine 45 degree is equal to 1 by sine 45 degree. Sine 45 is 1 by root 2 or 1 by 2? 1 by root 2. So 1 by root 2 gives root 2. Mu equal to root 2. Then we know the formula, actual definition, another definition for mu, refractive index. Refractive index is the ratio of the velocity of light in vacuum to the velocity of light in a medium. That is mu equal to c by v. C is the velocity of light in vacuum and v is the velocity of light in any medium. Then mu equal to c by v. Here we want to find v only. So mu equal to c by v, then v equal to c by mu. C by mu. What is the value of velocity of light in vacuum? 3 into 10 power plus 8 or minus 8? 3 into 10 power plus 8 meter per second. Then this is equal to 3 into 10 power 8. Value of mu, just now only we found, mu equal to root 2. So this is 3 by root 2 into 10 power 8 SI unit only, because we followed everywhere SI unit, meter per second. So 3 by root 2 10 power 8 meter per second. That is option B is the correct answer. Okay, I think most of you got this answer. Let's move to problem number 3. In total internal reflection, when the angle of incidence is equal to critical angle for the pair of media, two medium, glass with some other medium, air medium like that. For the pair of media in contact, what will be the angle of refraction? Glass with glass also may take. Okay, so we want to find what will be the angle of refraction when the angle of incidence is equal to critical angle. This already we studied in total internal reflection. In total internal reflection, there are two conditions. That is, light must travel from denser medium to rarer medium. That is one condition. Another one, angle of incidence must be equal to critical angle, equal to or greater than. And there we may study that if angle of incidence is less than critical angle, what will happen? Light will be refracted towards the another medium. And if it is greater than critical angle, total internal reflection takes place. And if it is equal to critical angle, that is angle of incidence is equal to critical angle, what will happen? Refracted ray grazes over the interface. Is it so? As per the diagram, refracted ray grazes over the interface between two medium. So what is the angle here? This angle is 90 degree. That is only angle of refraction. What is angle of refraction? It is the angle between the refracted ray and the normal. This n is a normal. So angle between the refracted ray and the normal, this value is 90 degree. Therefore, angle of refraction is 90 degree. Option C is the correct answer. I think maximum of students got answer in this question. Okay, let's move to problem number 4. A ray of light is incident at an angle of incidence I on one face of a prism of angle A assumed to be small and emerges normally from the opposite face. If the refractive index of the prism is mu, the angle of incidence I is nearly equal to dash. That is mu equal to sin I by sin R, and here R is the angle of refraction. Angle of refraction we have to mention in terms of emergent ray. That is R equal to 90 minus alpha. Alpha is the angle of emergent ray. And alpha equal to 90 minus C. We substitute this, then R equal to A. What is A? A is the angle of prism. And here is mentioned, assumed to be small. That is, angle is assumed to be small. That is, if angle is small, then sine theta equal to theta. If angle is small, sine theta equal to theta. Then similarly, sine I equal to I. And sine R equal to R. Sine I equal to I and sine R equal to R. Substitute this here. Mu equal to sine I is I and R equal to A as sine A as A. And here what you want to find? You want to find angle of incidence. So mu equal to I by A, then I equal to mu equal to I by A, I equal to mu into A or mu by A or A by mu. Yes? I equal to mu into A. I equal to mu into A. So which option? Option A. Option A is the correct answer. Let's move to problem number 5. A transparent cube contains a small air bubble. Its apparent distance is 2 centimeter when seen through one face and 5 centimeter when seen through other face. If the refractive index of the material of the cube is 1.5, that is mu equal to 1.5, the real length of the edge of cube must be dash. Which option? Option B or C? Yes, option C is the correct answer. Okay, what is the formula? Refractive index is a ratio between the real depth and apparent depth. And your apparent depth is seen from one face 2 centimeter and seen from other face 5 centimeter. Then net apparent depth equal to 2 centimeter plus 5 centimeter. 2 plus 5 equal to 7 centimeter. Then mu equal to real depth by apparent depth, and we want to find real depth. Real depth equal to mu into apparent depth. Real depth equal to mu into apparent depth. Mu already given. How much? Mu is 1.5. And apparent depth, net apparent depth, just now we found 7. So 1.5 into 7. 1.5 into 7. How much? 7525 and then 717, 10. So equal to 10.5. We didn't convert the centimeter to meter, so answer also in centimeter. Actually, we have to convert it to SI unit meter, but here, as all the option is given in centimeter, no need to convert, keep in centimeter. Then real depth equal to 10.5 centimeter. That is option C is the correct answer. I think most of you not getting this answer. Okay, this is the steps. Okay, let's move to problem number 6. A beam of monochromatic light is refracted from vacuum into a medium of refractive index 1.5. The wavelength of refracted light will be dash. That is, wavelength of refracted light means wavelength in the medium side. You know the formula. Refractive index is nothing but ratio between the velocity of light in a vacuum and the velocity of light in a medium. That is mu equal to C by V. And C equal to mu into lambda V. What is C? C is the velocity of light, and that is equal to, we know the formula for wave equation, C equal to mu into lambda. Mu is a frequency. When light travels from one medium to another transparent medium, its frequency constant, does not change. Therefore, C equal to nu into lambda V. Nu is the frequency which is constant and lambda V is the wavelength in the vacuum. V is a vacuum and this V equal to nu into lambda m. Nu, as I said, frequency is constant, same frequency, and lambda m is the wavelength in a medium. And we want to find wavelength in the medium only, wavelength of the refracted lights. Then nu into lambda, this one means lambda getting cancelled. Therefore, lambda V by lambda m. Then nu equal to lambda V by lambda m. Then lambda m equal to lambda V by mu. Now, question is wavelength of the refracted light compare with the wavelength of the vacuum. That is incident light. As nu value is given 1.5. Nu equal to 1.5, that is greater than 1. As mu is greater than 1 as 1.5, lambda V by 1.5 means definitely that value will be less. Therefore, lambda m is less than lambda V, that is smaller. Wavelength of the medium, that is wavelength of the refracted light, is less than the wavelength of the incident light. Okay, that is wavelength of the, as per the exam, as per the question, wavelength of the refracted light is less than wavelength of the incident light. So option C is the correct answer. Okay, let's move to last question, 7th question. A convex lens and a concave lens, each having same focal length of 25 centimeter, are put in contact to form a combination of lenses. The power in diopter of these combination is dash. Formula 1 by f, that is the focal length for combination. 1 by f equal to 1 by f1 plus 1 by f2. Capital F is the focal length of the combination. Assume f1 is the focal length of the first lens, that is convex lens, and f2 is the focal length of the second lens, concave lens. Okay, we know for convex lens its focal length is positive, and for concave lens focal length is negative. For convex it is positive, and for concave focal length is negative. So 1 by f1 minus 1 by f2, and both are having same focal length 25 centimeter. Then this is equal to 1 by 25 minus 1 by 25. So 1 by 25 minus 1 by 25 is equal to 0. Then 1 by f equal to 0. Then actually what is the relation between power and focal length? Power of the lens is nothing but reciprocal of the focal length. Okay, so P equal to 1 by f. 1 by f equal to 0. So substitute here directly. Power of lens equal to just 0. So option D. D option, that is power equal to 0 diopter. Actually, what's the unit of power? It's in diopter. So power equal to 0 diopter is the correct option. Okay. Okay. So in next session, we are going to discuss as usual. First, we will give 7 questions in one session, and next session, we are going to solve the solution for that questions. Okay. Thank you. Thank you, students.